VPC object tracking. In this video, I'm going to talk about VPC object tracking, and after that, I'm going to show you how we can configure object tracking in VPC, and finally how we can verify the VPC object tracking function. Let me to talk about this feature first in this scenario, and after that we can configure object tracking. Look at to this scenario. This is the same scenario. Here we have switch 1, switch 2, and also switch 3. Switch 1 and switch 2 are VPC peers and are residing in the VPC domain 1, and also the switch 3 has one port channel with the, for example, switch 1 and switch 2, and this is a virtual port channel. Look at here, I configured VPC 2 in the switch 1 and also for example switch 1 and switch 2, and after that we have the normal port channel with LACP on the for example switch 3. Let me to show you. This is our virtual port channel. One of the links is this link, is this interface, and the next interface is this interface. This is PO1, okay, and this is the PO2 in the switch 1 and also PO2 in the switch 2. These two PO2 are members of the, for example, VPC2. We will configure it, okay? You learned about the configuration, but in this video again we will configure the VPC. Okay, after that, let me to talk about VPC object tracking. What is the object tracking? Let me to talk about the object tracking. After that we can configure it. Look at here. Assume that switch 1 is the VPC peer primary and switch 2 is the VPC peer standby or secondary. Okay, you know that if a traffic receives to the switch 1 can forward the traffic and should forward traffic directly to the for example R1. For example, if we have this traffic, a traffic received from the switch 3 on the router 1, the switch 1 should normally locally forward the traffic to the for example router 1. Then the traffic should receive to the router 1, and router 1 can for example send this traffic to the outside of our network or anywhere. Okay, this is the normal behavior. And the switch 1 is the primary VPC peer. Assume that the link of VPC, the link of switch 1, the uplink to the core, for example, router, is failed. If this link is failed, okay, normally because the peer links or VPC peer link between two switches are up, VPC peer link are up, this means that traffic is receiving in switch 1 cannot send to R1, and this traffic now are dropped. Okay, this traffic are dropping, and after that we here we have black holing. Okay, why? Because we have switch 1 that it does not have any pass to the R1, but the traffic receiving to switch 1. Why? Because the VPC peer link is up, and because of that, switch 2 can't, for example, understand or doesn't know about the failure of the switch 1 uplink. This is the uplink of switch 1. Because of that, the traffic forwarded to switch 1 and then dropped. Again, traffic is forwarding to switch 1, then again dropped. Okay, and also you know that switch 2 is available, but because switch 2 doesn't know about the for example the failure of switch 1, switch 2 doesn't do any reaction, and also switch 1 doesn't do any reaction. For example, if the switch 1 understand the fail of this uplink, it can block its VPC member ports. If the VPC member port of switch 1 is blocked, okay, the switch 3 can send traffic of VPC, can send this traffic to the switch 2, and the problem is solving. But without any action, without any object tracking, the for example switch 3 doesn't know about the failure, and also switch 1 doesn't block the VPC member port, and finally the traffic is sending to the for example switch 1, and in the switch 1 the traffic should fail or should drop. This is the problem then that we can solve it with the VPC object tracking. Also, we have another function, useful function of the, for example, VPC object tracking. Let me talk about this function. Look at here. You know that we have a link between switch 1 and switch 2. We call it VPC peer link. And also we have one uplink. This is the uplink between the switch 1 and also R1. And finally, we have another uplink here. You know that by default, without object tracking, if the VPC peer link failed, switch 2 should block its VPC member ports. Okay, I explained this feature before, should block this VPC member port. And this means that, for example, if the peer link is failed because now maybe we have a split brain scenario, switch 2 now should block the VPC member ports of itself, and after that switch 3 can send traffic to the switch 1 and switch 1 forward traffic to R1. And after the VPC peer link is again up, go to the up state, the for example VPC member port of the switch 2 again should come back to the up state. But here we have a problem. Assume that we have a module on switch 1. In this module we have, for example, ETH11 and also ETH12 and also ETH14. ETH11 and 12 are peer link. Let me to right here, ETH11 and also ETH12 are members of the VPC peer links, okay? And also this is the ETH14, and all of these, for example, interfaces are reside in one module in the switch 1. After that, maybe in some cases, for example, one fail occur in the module of the uplink and also VPC peer link. Assume that this module in the switch is failed, okay? What is happening? You know that if this module is failed, the VPC peer link goes to the down state. And because of that, switch 2 should block its VPC member ports. After that, after it's blocking its member ports, now we have this condition. All traffic should send from the switch 3 to the switch 1, and switch 1 cannot send the traffic to the R1 because you know that this link now is failed, because the module is failed. And after that, the traffic receiving to switch 1 and the traffic should drop in the switch 1. This is the black holing of traffic. Also look at here, switch 2 has a pass, but because switch 1 doesn't send any traffic to switch 2, switch 3 doesn't send any traffic to switch 2 because this is the VPC member port of switch 2 now has block state. Now we have one problem. The problem is that switch 1 doesn't have any pass to R1 and all the traffic should send to the, now is sending to the switch 1, but switch 2 has a pass but it doesn't receive any traffic. This is the problem. We can solve this problem with VPC object tracking. Let me talk about that, how VPC object tracking can solve this problem. The VPC object tracking feature suspends the VPCs on the impaired device so that traffic can be diverted over the remaining VPC peer. For example, here I'm going to configure to, for example, tracking this interface, the ETH14 in switch 1. We configure a track, and this track should for example, track the interface ETH14 line protocol or maybe IP routing, okay? After that, after configuring this track, we can configure the VPC domain, for example, 1, with the track of interface. This is, for example, track 10, and we can configure track 10. What does it mean? This means the VPC in the VPC domain 1, we are tracking the track 10. This means that if the uplink between the switch 1 and R1 failed, okay, now VPC domain 1 go to down state. This means that although the VPC peer link has up state in the first condition, okay, because the VPC, for example, uplink, VPC peer uplink port now goes to the down state, this switch, the impaired switch, should block its member ports. Because of that, all of the traffic should send to switch 2. Assume